You will master Tekla Designer for basement building in this video. We'll consider all the techniques to model the basement building successfully. We proceed to loading, including the soil pressure load, the wind load, and all the necessary load successfully. We'll carry out the analysis of the building to make sure all of the structural element has been analyzed and designed successfully, including the foundation. Then we'll start to produce the detailed drawings for the shear wall, the beams, as well as the column. And then we will proceed to visualize the 3D reinforcement of all of the structural elements that we have designed in Tekla Structural Designer. Stay connected as we dive right into the presentation. Here is Tekla Structural Designer software welcome interface. We need to create a new project, but before then, we have to set the code of practice. So we click on the settings right here, and then we have the dialog. It will just like this. At default, we have UK setting active. So if you click here, you see other country code. If your country code is not here, you can use the import provisions. For instance, I select Sweden, and then I click on the OK options. So you can see Sweden is here, and then I click on active right here to make it active successfully. So for the sake of the presentation, we are going by the UK settings. So I click right here. So I have to click on the active to make it active, just like this. You can check other codes using this design code provisions for actions and resistance code successfully. So you can see the result right here. So everything is good. You can explore here as well. Then I click on the OK. We have done the necessary setting. Alright, so at this point, you can click on the material right here to set the materials for the reinforced concrete member over to reinforcement, and then you see the class at default is 500, and then you can see the reinforcement diameter right here. You can create yours using this provision, and then you can also add the rebar sizes using this provision as well. Okay, everything is good. Click on the close option. Now we want to create a new project. Click on the new option right here to actually create a new project. So new project is created successfully. You can see right here. So you need to save this project. If you right click and then you click on save as, and then over here you can give it project a name. So I want to call it FDV. All right, this is the project name. Click on save. You can use any name you wish. All right, so now we are good to start modeling. You see over here we have the structure 3D, and then you have the ST base. So these are the default levels. If you select there, you see the levels right here. ST base level. We have not created level. So go to modeling tab and click on the construction levels. Click right here. So over here, you can see since we have a basement, all right. So we have to insert above first. So we'll be having up to 4 floors, just like this. 4 floors. Okay. Now over here, just have to change it to XSL, which is structural slab level. Structural slab level. All right, even here as well. So this is top of foundation. So we need a level that is below this. So for you to get the level that is below this, just select this provision and click on this insert below. This option. So this has been inserted below. All right. So over here, you just have to key in minus 3 meters. Just like this, minus 3 meters. All right, so we have this place to be the 0 level. So at this point, we'll have here to be 3 meters as well, and then here is 3 meter, here is 3 meter, and then here is 3 meters. Sorry, we're supposed to key in this provision the spacing. Yes, 3 meters, 3 meters, and 3 meters, just like this. And then you see we have here to be 0 level, which is the base level. And this is the sub base level, which is the depth of the basement. All right, so we can just change that to basement. We can give it the name as basement, just like this. Okay, and then this is going to be natural ground level, so we get it as NGL, natural ground level, you see. And then here is going to be the first floor. Okay, so for the first floor, you just type first floor, FN, and then here is going to be the second floor. So you just type ND here. All right, so this provision we have it to be third floor. So for the third floor, we need to have this name to be RD. So RDF, all right, third floor. So this is second floor. Okay, then here is going to be the fourth floor. So we have this just like this. So this is how it's good that you name this so you can be able to understand it. All right, so everything is set successfully. So I have two foundation level, top of foundation level. Okay, the natural ground floor is going to be serving as a top of foundation, and then the basement is also going to be serving as top of foundation. You can see from here. So everything is good for the structural slab thickness. So we have it to be 180 millimeters right here, 180 millimeters right here, just like this. 180. All right, so we already have okay, we have reinforced concrete slab here as well, so you can key it in as 180, but just leave that. We can provide the thickness later. All right, so coming to the source, okay, we are going to be making this unique from the first floor. We click in this position, make this one, and then make this one. So this is a way of making it similar stories, you understand? So from story 1 right here, from 1 is a similar story up to story 4, which is the 4th story right here. Okay, so these ones are unique. You can see the natural ground level and the basement successfully. So this is the construction level I've set, okay, successfully in Tekla Structural Designer. So if you have any confusion about it, you can drop your comment in the comment section below. All right, I click on the OK option, so you can see all of the created right here. You can see. All right, so now we can double click here to actually make it active. So this is the natural ground level, and then this is the basement level. All right, you can see. So now we can be at the natural ground level. We want to set out the green line, so I'll click on the natural ground level, this one, and then I come to these provisions and I click on these rectangular grid lines. All right, so here we go. So you can see the names we have here. AG1, you can change it, the color as well can be changed, but I leave that at default. And then from here, you see all of this provision has been checked. That means this is going to be populated all through the stories right there. Okay, I click on next, and then it's going to start from the origin, meaning the green lines. All right, click on next, and then the line type, I will use this dot dash dot. Okay, click on next. So here in the S directions, we'll be navigating to AutoCAD. Now let's look at the this thing we have. All right, so here we go. So this is the green line set out in AutoCAD. I will send this in the description of this video. You can download it. All right, so you can use it to practice along. Okay, so now from here we start here. We have 1 meters. Here we have 2 meters, 4 meters, and so on and so forth. So let's get back to Tekla Designer. Okay, so we use the irregular. All right, so click in this provision. The first thing we have there is 1 meter. See the unit here in meters. So select there, use comma. The next is 2 meter. All right, you use comma again, and then the next we have is 4 meters, and then do comma again. The next we have is 2.4 meters, 2.4. Just like this, you do comma, and then the next right there is 4 meters again, then you do comma. So we have 2 meters, comma, and 1 meter, just like this. So this is the green line set out in this X direction extent. Okay, go to next, and then this is the irregular length in the Y direction extent. So click in this provision, so we can also check that in this direction. We'll be having 1 meter, 3 meter, 3, 2.4, and then we have 3 meter and 1 meters. Okay, so let's proceed from here. 1 meter, comma, we have 3 meters, comma, 3 meter again, comma, and then we go by 2.4, and then comma. So we proceed to 3, comma, and then finally 1. So you can see the green line set out just like this. Click on the next option, click on the next option, and then click on finished. There we go. We are down setting out the green line. At this point, we want to start to model. So we start the modeling from the basement. Okay, so we select in the basement right here. So here is the basement. Okay, all right, so now we want to start by modeling the concrete mesh. Okay, for the concrete mesh for the basement. So we have to just select on this, use the first option, concrete mesh, click right there. All right, so now this will set the top and bottom constraint. So the bottom constraint is basement, and then the top constraint of this, I'm going to make it natural ground level, this one, you see. So we scroll down so we can set the thickness of the basement. Okay, for the reinforcement we use loose bars. Okay, so we screw down. Here the basement thickness is 250 we used, so 250 you key in. All right, then we screw down. The nominal cover from here is 25. We are going to be using 30 right here. All right, just like this. So these settings are good. Every other thing, leave it positive. So we want to start to model the basement. So we start from this point, click here and click this place to have a place you can see. So continue to click just like this. All right, so we have to escape from here. So once I escape, I will now start from this point. So you can double click to pick it again just like this. So I'll click here, double click to pick it again just like this, escape, pick from here, double click. So this is actually connecting the basement and the natural ground level. So we are done with this. Okay, if we go to 3D, you see what we get just like this. All right, so we get back to the basement again. So now we want to also be drawing a shear wall using this same method, but this time around it's going to be connecting the basement and the topmost story. All right, so now to do that we need to click in this provision, use the option. So now the top constraint this time around is going to be up to ST4. All right, then screw down to check the size of the basement. Okay, right here we'll make it 250. All right, screw down, and then the nominal cover is going to be 300 right here. Sorry, 30 millimeters. All right, so after which we are good. So we are going to be drawing from this point up to this point and up to this point. All right, so over here we have the same thing to connect this point and this point. Okay, so we also have to connect from here and here. All right, so the same thing right here, just like this. Click to have it placed. Now we have a lift well. A lifter we have is in this provision, so you just select it from here, pick there, this point and that point successfully. So this is good. Let's go to 3D. So this is what we get, you see. All right, at this point we want to start to place the reinforced concrete beam. So we place the beams at the ST natural ground level, which is this level, this one. Double click right there. So here we go. We want to start to model the beams, the first concrete beams. Click right in this provision. Or do we model? Okay, let's model the column first. So select on the column. This is the first concrete column. Okay, so this column now is going to connect the basement, all right, and the topmost story. The basement and the topmost story right here, you can see. So we screw down for the column section. So at default we have 400 by 400 millimeter column section. So click right here. We are going to be having 225 column section by 400 or 450, just like this. So we click on the OK option. All right, so for these columns you can see the base constraint and the top constraint. So we are going to be having one of it right here. We have a column here, you see. We have another one right here. You have it here as well. You have it here. So later we check anyone that is not in the plan, we get rid of it. So here is the columns you're having right here. So after we have done this, now we can now proceed to model the beams. Okay, so let us navigate to the 3D to see what we have done. So you can see this is what we get back to the base. So at this point let's get back to AutoCAD and see what we get here. Okay, we have a column 3 it right here. Okay, we also have 3 right here. All right, so we need to correct that. So come over here. These 3 columns are not supposed to be here, so get them selected and then hold the Control key and select these other 3 as well. Click on delete right here and then click on the OK options to get rid of that. So we are going to be remodeling these columns again, but at this point. All right, so for you to do that, you have to get back to column, click right here, and then the top constraint is going to be ST4, while the base constraint is going to be natural ground level, this one. Then screw down to choose the right section. So here is the section. Here we go. So now for the alignment of these columns, we need to use the center to center. All right, we'll correct that later. So just do a window over these grid lines to have a place just like this, you can see. So now we need to align it. So if you select these columns, select on it, hold the control key, select this one, hold the control key and select this. And then come to the property dialog and you see alignment. Expand it. For the left provision, use center to centralize it, you can see. So we pick on the column as well. From here, the same thing right here. Let's check the section. If it is correct, that's good. Okay, so now we apply this right here, just like this. So we have to also select this, hold the control key to select multiple of it, just like this, and then scroll down for the alignment, expand this provision and change the right to center, just like this, to centralize it. So from here, if we get to 3D, you can see what we get. You see. So now I want to start to model the beam. We get to the natural ground level. We have a beam connecting all of these provisions. So click on the beam right here. So we scroll down, see the materials and the beam properties. Let's check the sections. So we are going to be having 225 beams from here, 225 by 500. Click on the OK options. All right. So now we want to be creating a beams that will connect this point. So pick the first point. Can pick it all through to have it placed, but if you select it, you can see it is actually a single beam, a continuous beam is being placed successfully. All right, this is good. And then come in these other directions, you have to also click on the beam option, check the property, everything is good. So you can pick the first point, pick the second point, just like this. So the last one you have to double click to have it placed. So the same thing applicable here. So you just have to, the last one, double click to have it placed. So from here, you have to double click here to have it placed. So you can do a window just like this, release your hand to have it placed as well. Also do a window just like this, release your hand to have it placed. You can see what we are doing right here, just like this. So we are good. Okay, so this is nice. We are done along this line. We wouldn't have beams. Okay, if you go to the 3D, this is what we get. So you can see the basement right here. All right, so now we are good. We get to the ST1, which is the first floor level. This level, we need a beams right here. So click on this beam member, and then the sections we go by this. The nominal cover, this is okay. So we can choose from here and do a window over this columns point, release your hand to have the beam placed successfully, just like this. And then other ones, you can decide to pick the first point, pick the second point, double click to have it placed. Along this line, you can just do a window just like this, release your hand. The same thing here, release your hand. Okay, so from here, pick that point, pick this, double click to have it placed. Pick this point, double click here to have it applied successfully. Same thing here. Okay, so now for these beams, we need to extend this. So click on this beam member again in the property. You have to check the section. Everything is good. You have another beam right here. You have another beam right here, just like this. So this is how you model this type of structure using Tekla Structural Designer. Just like this. So we have the beams here, but the beam we have here is going to be a cantilever beams. Okay, so let's get to 3D. So this is what we get. You can see I've already populated the beams. All right, all over. So get back to the ST1 again. We need a cantilever beam right here. So let's see how to model a cantilever beam. Okay, so this beam from this point to this point is going to be a cantilever beam. Pick on this, on the beam member, come to the property dialog, check the section. We go by the same section. So this point you are picking is the first point of the beam, and this is the second point. So at the second point, double click to have it placed. So this is the cantilever beam. You can as well escape from here Pick the first point, double click on the second point to have it place cantilever beam. Pick the first point, double click on the second point, and then get back to activate the beam. 2. Pick the first point, double click here. Alright, this one is not a cantilever beam, so just double click to have it placed, escape. So just like this. So activate the beam member again, pick that point, just like this. Okay, over to this side, you do the same thing. So this is the first point, and then this is the second point. First point, second point, first point, second point, first point, second point. All right, so yeah, just have to model this way. Okay, so now we have modeled the cantilever beam. You have to make it a cantilever beam. So select one of it, hold the control key, select multiple of it, just like this. This was our cantilever beam. All right, so come to the property. So in the property, if you scroll down, you will see a provision where we have to define the release, the beam, whether it's a cantilever beam or not. So as you scroll down here, you see we have releases, select that, and then you see cantilever end 1, and then you can see over here we have cantilever end 2. All right, so now we activate the end 2. Okay, so this has made this end a cantilever suspending. All right, so after which we scroll down, come over to this provision, select this one, this, and this. It's also a cantilever. Scroll down and make them cantilever, released. So this time around this end 1 and this is end 2. So we scroll down to the end 2 and make it a cantilever, just like this. All right, so now click on the beam command, scroll down. So this is the section, so we are going to be having, pick on that point, double click right there, pick on here, just like this. All right, just like this. Come over to this side. We need to add a beam, so I just continue to pick, and at the last you double click. So you see the various ways to model. So now go to 3D. Let's see what we get. So you can see what we get here in our model. Everything is good. All right, so now we want to apply the reinforced concrete slab. We go to the natural ground level. We need a slab right here, so just click on the slab on beam, the first option. Okay, so create slab item, close bar. Okay, escape that, go to the ST1. All right, here we go. This is ST1. We click on the slab provision. All right, so we want to create an existing slab, next one. So if you scroll down right here, you notice we have the depth key in before, so everything is good. Over here, it's a two-way slab, so you can actually do a window over the beams, release your hand to have a slab placed successfully, just like this. We'll remove this one right here, escape to get rid of the command, and remove this one. That is for the lift well, delete that successfully. Go to the 3D, you see. So we have populated this with reinforced concrete slab successfully, as you can see a model. So this is how you model the basement structure using Tekla Structural Designer. Okay, so for this provision we'll also apply reinforced concrete slab at the natural ground level, but we did not assign the slab thickness to this. We did not assign, that is why you see this. Okay, but we can get rid of that successfully. So to actually correct that issue, if you come to this construction level, you notice that we define this natural ground level as top of foundation. So you have to change this to structural slab level. All right, and then you come over here to make sure you give a thickness to the reinforced concrete slab, just like this, to correct that error we are having. So click on the OK options. So now we have done that setting. Come and click on the beam option. You can see everything is good. It's not showing red alert right here. So up here, I will have a new slab. So I go by the slab thickness that we just set, which is 180 millimeters. All right, so I can now do a window over the drill intersection, reduce my hands to have the slab placed successfully, just like this. I will escape from the command, click in this provision of the lift well, and then I have to delete this up. Okay, so in this other provision, you can have the slab placed manually by clicking on it, and then you can just okay, but this is not actually prompting. See over here, select bar. So this select bar, if you click here, it will actually play the slab, but it's not working here. So since this is not working, uncheck this select bar, then I can be able to pick from the first point, second point, third point, double click here to have it placed. You can see. So this is sent in here. Double click here. Sorry, it's not properly placed. Double click to have it placed. Alright. So if you need a master's training on this program, you can reach to me through the link in the description of this video. Alright, so let's place this successfully. Double click right here. This is good. Escape right now, and then go to the 3D. So yeah, we go. This is what we get. So at this point, we need to load this model, but before we proceed, we have to correct some of the modeling aspect of this structure. So at this particular provision, we don't need reinforced concrete slab here. So I will select this, and then I hit on the delete provision to get that deleted. Okay, also these provisions we don't also need slab, so I delete that. So as you can see, as I deleted it from the first floor, it's also deleted from other floors, and as well as the beams right here. So I have to get rid of it successfully, just like this. So this is what we get. All right, so we now have to apply it the beams that actually close up the slab edge right here. So the same thing is applicable to this provision. So I will have to just select on this reinforced concrete slab right here, and then click on the delete options, and then select on this as well. Click on the delete option, and then you have to select on the beam right here. You see this beam. All right, so I will pick on this and then click on the delete options. That is gone. All right, so having done this, you can now have to navigate to the ST1. So at the ST1, you can see where we remove beams right here. So we need to apply another beam. Of course, you have to go to the modeling tab and then come to beam options, and then the beam depth we used is 225 by 500, which is this beam depth. Everything is good right here. Okay, so now we just have to pick from this point, double click right here, and double click here to have the beam placed. Okay, the same thing here. Click once here, double click here, just like this, and then you come over to this side. So you pick here and double click here to have a beam, pick here and double click here to have a beam. So over here you pick here and then double click here to have a beam successfully. All right, let's go to the 3D. Here is the 3D. So this is the model. This is how it's supposed to be. All right, this is the model, you can see. So at this point, you want to start to load this model. So before then, you have to validate the model. So you click on save options and click on validate. So under validate, you can see some warning sign right here. Expand it to know what the warning is. You can see over here, it is loads, empty cases. All right, so we wouldn't have load yet. That is what we're about to do. That is why you are seeing it telling you that you have not loaded the structure. Okay. Now I will save this model again, and I come to the load tab, and then I click on the load cases. So over here you can see I have default load cases here in Tekla Structural Designer. So I don't want the service load, I can delete it. So any load you don't want, you can delete it. Here is the impose load. All right, so now this is the impose load. You can give it another name. So I can call it office impose, okay, or residential impose. All right, so this building is basically for office. It's a commercial building, so you can just use office right here, just like this. So this will now turn to be office impose. Okay, so I will get the name right from here, office impose load. Right, just like this, office impose. Okay, just like this. After which every other things here, you can see the category B is office, so you have to make sure you choose that successfully. You can see domestic here, you can see congregations, you can see shopping, storage. So we use this category B for that import load. So other import load, you can as well create it. Okay, so you can click in these provisions and add it here. So once you click on add, you see load case here. So let's say, for instance, we're having load case for soil pressure. So you can just type in soil pressure, just like this. All right, so now for the load, you use this other impose. All right, use this other impose. Okay, and then for the combination factors, right here, we go by 5, 5, and 5 in these provisions for the combination factor. So we can add other loads, like click here to add it. Then over here, we change it to the roof impost. So this is going to be roof impost load. So over here, or you can just be able to copy from here, but it's not possible. So you key in right here, roof impose, just like this. Okay, so for the roof impose, you have combination here to be 0.7 right here. Okay, so these are the loads we are going to be considering. So we have created them, so you can create as many loads as you want. All right, so if I click on this office impose, you see pattern, eccentric moment. For precast concrete, you have to uncheck these provisions. We are not looking at precast. Okay, so after we click on the OK options, so we are good. Now we have load cases created. So you see over here, we click here and then select here. You see all the cases here. We'll start from the dead load. So I select on this dead load options. Then for the dead load, we are going to be looking at this perimeter load. So I click right there. So it set the direction of the load. Over here, we go in the Z directions, and then the load value is going to be 10.5. This is for the wall load. Okay, 10.5 I used. So you just put your hand like this, click in this provision, and then click here to have it generated. You can see here is the dead load. All right, so this is the dead load we have on this structure. So now, while we click in this provision and choose the office impost load. So the office impost load, I have to escape from the previous and then choose this office impost load, and then I will be using these options of level load. Okay, this level load, click on it, and then it's going to be in the global Z directions. And then for the office impost load, I'll have that to be 2 kilonewton per square meter. So now I will pick in this at this level to have it placed, pick here to have it also placed successfully. So we have actually applied the impost load successfully on the model. So I click in space and escape, and then select in these provisions to choose the soil pressure load. So this soil pressure load, you have to pay close attention to how we had this in Tekla Structural Designer. Okay, so to have soil pressure load, after having selected it here, you need to come over here. You see what varying area. Okay, so you have to select it right here. Okay, so for this load, we'll be using this is load top and this is the bottom. All right, so at the bottom, we are going to be having it to be 3 kilonewton right here, 3 kilonewton at the bottom. So at the top is going to be 0 because this is actually the normal ground level. So at the normal ground level, you see it is a varying load. There is more soil at the base than the topmost, the topmost level of the basement. So that is what this simply means. And then once you have this load value applied here, you need to go to the directions and change it properly. So we go first in the global X direction, right? So when we're going in the global X directions and you want to place the load, so you need to check the UCS icon. Just orbit the model like this to check the UCS icon. So you can see the direction X is facing. So now if I pick on this, you can see the load right there. It's facing this way. I pick to have the load placed. So this is the soil pressure load I'm actually applying right now. You can see. So I click on the shear wall to have it placed successfully. If I click on this, you can see the load actually distributed even up to the last floor, which I wouldn't want to place it on this wall. Okay, so I've done that. So I can now change the direction to the Y direction. This is the Y direction, so I can place it here as well. So this is being placed from the inside. okay, because of the directions of the UCS icon. All right, so but this is supposed to place outside. Okay, it is placing inside. So what you do, you have to undo the first undo, the second undo. Okay, this has been removed from here, so change this as well, the X directions, and then be able to apply this again, just like this. So for this side of the building, you can actually prefix this with minus, just like this. Also prefix this one with minus, and then you click here. All right, this is the X direction, and then click here to have it applied, just like this. Click to have it applied, just like this. Okay, so for the Y, let me check this side. Okay, this is placing inside. So for the Y directions, change this position to Y, which is the direction to Y, and then you click. This seems to place the load inside. Okay, so all right, so this is correct, and I have the load just like this being placed. Okay, this is good. And then you have to remove the minus sign right away, and then navigate to the other face of the building, and then apply the load just like this. All right, so you can see the way I applied the soil pressure load on this wall successfully. This is how it is being applied in the Tekla Structural Designer. Okay, so if you have watched this video to this extent and you have not subscribed, and then you have not liked our video, hit on the like button, subscribe, and stay connected as we make progress. We want to proceed now into the wing load. Okay, let's check if there is any other. Okay, roof imposed load. We have to apply this roof imposed load, so select on that. So having select on the roof imposed load, we will also use the the level load to apply this load. So this load is supposed to be actually on the roof, but since the levels are similar, okay, we are going to be using a minimal load of 0.1 kilonewton, and then we click on this level to have it placed successfully. You can see. All right, so now we are good. We have successfully applied all of these loads. Now you want to apply the wheel load, so you will learn how to apply wheel load properly in this video. So let's see how to apply wheel load. I want to save this right now, and then I click on validate. So you can see what we have here. If we expand here, you see non-vertical load, a non-mesh, and then you can see all of that. So that is not an issue. So let's see. Okay. So you can see the load we applied, the one we applied recently, which is the roof imposed, is not properly applied. So now if you click on this, if you click on that load, you make the load active, and then you select on it. So you see the direction of the load. Roof imposed load is being applied in the Y direction. So select it right there and take it to the Z direction like this. You see. So that has changed at this floor. So you have to select it at this floor, and as well change it here to the Z directions. Okay. So select on this, change it to global Z directions, and then over here the same thing, change it to global Z direction, just like this. So you can as well select on this. If you try to delete this, you see all the load is gone. The roof imposed is gone because the story are similar. All right, so let's apply that as well. Click on this slab. Once you click on that over here, change these directions to the global Z directions. Use these options and then pick at this level to have it applied just like this. Click on the validate. So now you can see the model is validated. Now we have no error in modeling. All right, so everything is good now. I escape. So before we start to apply the wheel load now, we need to provide what we call, if you come to the modeling tab over here, you can see wall panel, and then we also have roof panel successfully. So click on the wall panel, and then I'll pick the first point. All right, on the wall escape, I want to pick it correctly, that point, and then I pick the second point, pick this point to have it applied successfully. Pick the first point right here, pick that point to have it applied. So that is the wall panel we are actually applying. This wall panel will actually help us to apply the wind load successfully. So you can see over here in the property dialog right here, you see rectangular is being checked. So I'm applying it, I'm picking it in a rectangular form, so I can pick the first point and pick the opposite side, okay, of the first point to have it placed successfully, just like this. So I have applied the wall panel successfully on this model. So for the roof panel, you just have to click in space and escape. From the wall panel command, click on the roof panel right here, and then over here you can pick the first point, pick the second point, you see, go straight away, third point. The first point, once you pick that point, you just enter on the keyboard to have it applied successfully. So now that we have applied the roof panel as well as the wall panel on this model, you will see that if you come to the load provisions, you see the wind wizard is now active. All right, so once that is active, just click on it. All right, or before you click on it, let's just close or cancel this first, and then click on validate to validate this model. So everything is good from here. You can see the statute. All right, so now we proceed. You click on the wind wizard. So from the wind wizard, you can see the northeast-west cardinal point. Okay, so this shows you the directions of wind on this model. Okay, so now from here, I will be choosing the worst case data, okay, because I don't have any data, so I will just use the worst case data for this analysis and design. All right, so after which, for this option, see consider orographic, consider tall neighboring structure, consider obstruction. I will choose obstruction and then uncheck that options. So these are the two options I will check for the data source. All right, then after which I click on the next option. So in the next option, you see site altitude in meters. So I will have 200 meters. All right, then for the air densities, I will go by this default air density, and then you see fundamental basic winds velocity. So I will use 25 here as the wind velocity in meter per second. All right, so all of these provisions I can leave them at default and then use building height right here. So after we click on the next options, and then the terrain category, I will use country right here, and then you need to provide the upwind distance from sea to side. This is in kilometers, so I can use 20 kilometer right here. So this is good. I click on next option. So over here, you see, I have the wind coming in 4 directions. The 0 direction, 90-degree directions, 180-degree directions, and then 240-degree directions. All right. So I don't want the wind. My wind for this design will be coming from 2 directions: the 0 direction and the 90-degree direction. So I will select on this 270-degree directions, and then I click on the delete options. So you can add directions, you can as well delete directions. All right. So I click on delete directions right here to get rid of that. So for the 180, I click on delete as well to get rid of that. And I'm going by 0-degree directions and 90-degree directions right here. Okay. All right. So I click on finish options after I'm done with that. So that is gone. And then if you check very well, you see nothing is being applied on the model successfully. Okay. But that is not a problem. All right. Because we have not done any further things. So here, after which you just come to these provisions and click on the update zone. So once you click on the update zone, you also notice we already have the wind being applied. So come to this provision where you have the wind load cases. Very, very important. You have to click on that. So once you click on the wind load cases, and then for the structural damping, you leave it at 0.05 right there, and then you have to click on auto, or you had it manually, but we use auto options. Click right there. So once you click, you can see what we are having right here. So we have the wind 0 degree, we have the wind 0 degree CPE on. I have to check that, and then 90-degree CPE on. I have also to check that. Okay, successfully. So everything is good here. I click on the OK option. So once I click on the OK option, you will notice that the wind load cases is only has been actually generated. You can see it from here. It's actually generated. You can see. Okay. So after which you come to the provision and click on decompose. Once you click on decompose, it simply means the wind has been decomposed on the structure. So if you click in this provision and choose the first one, you can see the wind loads properly applied successfully, as you can see on the model. And then you can choose the next one, which is the Win 0 CPE all. You can see it right there. It's been applied successfully on the structure. So you can also come to this window, click on the wing options, and then you can see the wing pressure zone is being applied successfully. Expand this right there. You can see the 0, and then you can see the roof zone. You can see the wall zone. If you select on this, and then right click, and then click on open. So this is going to open, this wing interface. And then you come to these provisions, activate one of the wing zone right here. Let's say I go by this 0 wing CPU. So you can see the wing right here. So from here, you can see the direction is 0 directions. Okay, and then you can also check the CPE positive and negative, and then you can check the net pressure on the model. You can also check the area of the wing on the model. You can see right there, and then you can see the arrow. This is 0 directions applications right there. So you can also change that to 90 degrees, and the arrow change to this other phase. So you can take the apply load successfully, which are the apply wing load successfully on this model. Okay, so if you want to learn and understand Tekla Structure Designer from A to Z, join our masterclass to the link in the description of this video. At this point too, do not forget to like, do not forget to subscribe. Let us make progress. So after having checked all of this, you can check the braid as well as the roof zone, roof type, and the rest of that. All of this, you need to actually check it and then be sure that this green check is there, which actually shows that the wing has been applied successfully on the model. All right, so once you are done with this, we are good to go. You have to get back. You want to go into the analysis, but before the analysis, you need to create the loading combinations. All right, so these are load cases for the wing and our normal loading. Okay, so for the load cases, for the loading combinations, come to the load case provision and click. So over here, before we wouldn't have this wing, you can see we wouldn't have all of this, you see. Okay, but after we generated the wing load, we now get all of this successfully. Okay, now we want to do the combination. Come to this combination option right here. So we go straight away. We want to generate it from code of practice, Eurocode, United Kingdom. So I click right there. So over here, I want to be using this table 1. I get rid of all of these options, and then I use the final scenario. Click on the next option. So over here, so this is what I get here. I click on the next option. All right. So over here now, I will choose this. I'll apply this positive direction 1, and then I will come to direction 2 positive, and also check that. This is for the wind 0 CPE all. Okay, for the wind 90 degree CPE all, I will check this, and as well check this successfully. Okay, I click on the next options. Here we go. So I choose the positive direction 1, and then I also choose direction 2 positive. I click on finished. So this will generate the combination successfully and apply the wind into the combinations, as you can see. After which, I click on the OK option. So now I click on the OK option. I can save this model, and then I can validate this model. So you see the validation, everything is good. At this point, you want to carry out the analysis on this model and check the analytical result. So you go to the analysis, and then I can decide to use the first order. It's very important. I click on the first order, check the combinations, check the load cases, and click on the OK options. So you have to give the program some seconds to actually carry out the analysis on this model. Here we go. Analysis is successful. So over here, you see the win 0 minus CPE all. I will go straight away to select the load case. Sorry, come to this option. Click here. I use the first final scenario load cases. After which you can click on the result right here. So this has given us the axial forces on the vertical member successfully. From here, you read that if you select in these provisions, and then you can see the shear measure right here. These are the shear measure. So if you want to look at the result, maybe you want to actually increase the scale on this, you can increase it. You can use these provisions. Okay, Now we can also come to these provisions and then you check the moment. Let's say moment measure. You can see the moment measure right here on that strength, and then the only analysis we have is first order. And then you can right click as well and check the illumination. It's not showing, but you need to activate the deflections via click on the deflection. So you see the deflections right here, and then you can be able to right click and check the illumination now. So you see the illumination on the structure. So the shear wall have actually keep the structure very stable, as you can see from here. All right, structure is very stable. All right, so now I close this. You can check other things that you wish to check, like the forces, okay? But for now, we can look at the reactions. If you click on this ID right here, you will notice that we have some reactions lines on the reinforced concrete column, but not on the walls. Okay, so now if you click on the reaction right here, you can now see the reactions. I can see I have a load of 453.7 kilonewton. All right, and then there are other places I have 520.4 kilonewton successfully. All right, so now these are the load we are going to be supporting with the foundations. All right, so having done this successfully, we can click in these provisions and get back to the structural view. Okay, now we want to proceed to the design, and then if I click on this design options, and then I will use the design or statics options to carry out the design of all of the structural elements successfully. Click on that, and then you give it some time to carry out the design. So design is in progress. Good. So design is successful, as you can see from here. Design is successful. We can now start to check the members. We are having just at warning on these beams because of this shear wall that you have this warning. Okay. Otherwise, the beam has been designed. For instance, if you select this beam, right click on it, and then you can check the design member options right here. If you select on the design member options right here, you will notice that we are having some warning right here on the depth of the beam. Okay, I click on the close options, so we can also check the wall as well. Right click on the wall. Having selected it, you can also do an interactive design for the wall. So over here you can see the wall here. The thickness is 225 and then the length is 400 millimeter. These are the reinforcements selected for the wall successfully, the lateral and the longitudinal reinforcement. Interactive diagram successfully. All right, and there is the U ratio. You can see it very clear here. Okay, so you can view the drawings right here. So once you click on the detailed drawings of that wall, this will open it in AutoCAD and to show you the detailed drawing of the wall you selected or any structural element. It could be the beam, it could also be the columns. So this will open AutoCAD automatically from Tekla Structural Designer to show you the detailed drawing as you can see from here. So I click on the no option. So this is the plan of the wall, and this is the reinforcement detail as you can see from here. Then you see the elevation and the detailing of the wall successfully. I'll minimize this right away. I close this as well. Okay, so the same thing applicable to the beams. If you have been in our presentations for some time ago now, we have been doing a complete design and checking successfully. The same method you will use to check this as well. So now we want to move straight away to design of the reinforced concrete slab. So I select these provisions and then come over to the structural view. So we want to design the slab right away. So for the slab design, you have to navigate to the design tab and then you see this option of slab design under the design tab right there. Okay, so you just have to click on that options to have the slab design. So click right here. You give the program some time. All right, here we go. You see you have 124 numbers of reinforced concrete slab designed successfully. You can see. So if you place your pointer on the slab, you can see the reinforcement selections and the spacing, which you can actually manage successfully in Tekla Structural Designer. And the slab thickness is 180. You can see in the info right there. Okay, now we are done with this design successfully. And then from the info, you notice that you have top 1, top 2, we have button 1, button 2. This simply means the first concrete slab has been designed as a double reinforcement. Okay, so now we proceed to the foundation design. But for the foundation design, we want to actually specify the core wall in Tekla Structural Designer. I click on the validate right here to have this validated, and then I select in these provisions and get back to the structural view. Okay, so I can come to the scene content right here, and then I get rid of some of these structural elements like the members right here. I can get rid of them. I can get rid of the wind panels. I can get rid of the roof panels just like this. I can also get rid of the slab items right here, and then I can as well get rid of the slab opening, but I don't have any. So here we go. This is what I get. I want to actually identify the core wall and then analyze this structure again, design it again, so that you can actually see the reactions that this wall is actually generating. Okay, like in terms of the axial load from the wall. Okay, we have not really seen it because it was not actually identified. Okay, so now you go to where you have the modeling right here. I click on this core, this one, select on it. So once you select on it, so with the capacity of 20%, these are the keys. This one is this color is meant for the member of core, and then this one is for the member of another core. This member of no core, you can see. So all of these are member of no core. All right, so I will select this particular one right there. So this has now become the member of active core. All right, so with this, after analysis, Tekla Designer will create an imaginary line that we actually help us to get the reactions that is coming from this particular wall I've selected so far, after which I can validate from here. Everything is validated, everything is good. I escaped. So now we need to come to the analysis tab, and then I can do this analyze all static options. I click right there. All right, so analysis is done successfully. Now you can see from here, Tekla Structural Designer have actually created, you see this? You can see here, this is an imaginary line between this core wall right here. So from there, you will now be able to have the reactions for that particular provision. If I select on this ID, select it back again, so you can see that reactions is generated right here, and the forces successfully. Okay, so now we are good. Come back to the analysis again, and then we'll do the design or static. Design tab, design or static. Click right there. All right, so the analysis and design is done from here, as you can see. So we proceed to the foundation design right away. So for the foundation design, you need to navigate to the basement level. If I click here, here is the basement, you can see. So I will go to the foundation tab, and then I'll use pad base first. I want to check something, so I select on the pad base, and then I will need to select all of these columns to have the pad base inserted. Select here to have the pad base inserted just like this, after which come to the property window, and then you can be able to check the LX and LY of the footings, which are like a temporary settings, and then the depth is 750. Okay, so this like an input data, they are not being designed. After design, you will be able to see the right section selected. So for the bearing capacity, I'll be having 200 kilonewton per square meters for the bearing capacity right here, just like this. Okay, So after which, I think that is all what we need to actually look at here. So after which, we click on this design part basis. So I select that options. So all of the part base will be designed successfully. So let's see the result of the part base design. We are good. Now you see all the part base has been designed successfully, and as you can see, the base are too large. You can see from here, I'm having the depth to be 350, and then you can see it's 3 meters by 3 meters sections for the base. So this is too large. So with this, we cannot be able to proceed with pad footing. We are going by raft because we also have a wall here. So by the time you apply base to the wall, now you see everything will like more or less a raft, you understand? So we go by raft instead of a pad. We won't go by these options. Okay, so what you need to do is we have to get back to the the structural view. Sorry, this is the server view. We go to the structural view just like this. So after which we can decide to select the pad basis just like this. We get the pad basis selected just like this. So I hold down the control key on the keyboard, and then I'm able to select a multiple of it just like that. Click on the delete options. So you check here is the pad base only. We have click on the OK options to have them delete successfully. So after which we have to validate the model. So we go by the raft foundation. So for the raft foundation, we will use this rectangular options. All right, in one of the video we use the stripped options. So now we use rectangular for the raft. So I pick on that rectangular. So now this is the overhang. I will first, the slab is going to be a new one, and then this is the overhang 500. I'll make my overhang to be 1 meter, which is 1000 millimeters. Okay, so I'll scroll down, and then you can see the slab type is foundation mat. Okay, then I'll scroll down. So the overall depth I will be using 200, or I can use 350 right. Yeah, to be on the safer side 350. Okay, so having selected that, I can scroll down. You see the concrete class I'm using, and then I come down as well. So over here for the bearing capacity, I have to change here to 200 kilonewton per square meters. And then over here for the horizontal support is going to be fixed. So you can as well use free. You can use spring, but we use fixed in this video. And then for the stiffness, we use 400. So this actually shows that the soil is not that good. It's not that good. Okay, this soil of 4,000 kilonewton per cubic meters. Okay, stiffness is not that it's not that good. For good stiffness, soil should be having from maybe 4,600 or up to 8,000 thereabout. All right, so now we scroll down. Let's check other options we have here. So we have an imposed load reductions right there. You can apply 30% imposed load reduction here according to the code of practice, United Kingdom Euro code. Okay, for the reinforcement over here, you see we have the bar type, the loose bars, and then the bar spacing is 200 right here. Okay, for also bottom side, and then you can see the top bars as well. So all the bars are here. You can as well view them successfully. So having do all of these necessary settings for the foundation mat, we now start to place the foundation mat. So what you need to do is just to select on the walls. Okay, if you select this wall, you see the mat right there being placed. Okay, now if you click on this, see it. So I'm picking on the wall just like this to place the mat. I'll select on this. So once I select on this, you can see how the mat is being applied successfully in Tekla Structural Designer. So having selected all the walls, I did the mat like this. So what you just need to do is to enter on the keyboard. So if you enter on the keyboard and then you right click right here, select the last wall and then double click to have it placed. All right, so now you double click to have it placed. It seems you're having double mat here. So let's get to the 3D right here, and this is not showing in the 3D. Why is it not showing the 3D? Right click from here and get to the structural view. So you have this. Okay, so come to these provisions and then be able to activate the members, activate the slab. So you have the slab right here. So you can see just like this. Okay, so to have this work effectively for now, if you click on the validate right here, you see the validation is still showing us modeling warning. So if you select here, you see you have support existing within area of mat. If I expand this, you can see it very well, area of mat foundation. So we have some support right there. So the mat foundation itself is a support. Okay, so you wouldn't need any support. Okay, so what you just have to do is we get back to the basement, and then we need to get rid of the support that we have right here. So I can select this mat foundation. Let's just get rid of it from here. Select it just like this, and then if you right click, so over here I'm checking something here. All right, okay, I couldn't see what I'm looking for. I want to hide this in view. Okay, so I can be able to select properly. I can be able to select the what do you call that? I'll be able to select the support. Okay, so now I can't select the support, so let me undo all of this. What I will do, I have to select all of this, and then I do delete from here. All right, the mat is actually deleted. That is not what I intended to do. So let's get to the 3D. I want to get rid of the support, so I can see if I'll be able to select the support from here. So you can see that I cannot be able to select the support from here. So selecting support is becoming difficult for us to do. So we need to remove this support. That is what, okay, that is selected. So if you click on delete option from here, you see that support is deleted. So I can select multiple of it. Having selected that one, I hold the control key to be able to select multiple of it, just like this. You can see. So we want to correct the warning that we were having right there. So we need to do this. It's very, very important. So I select all of this just like this. You have to be careful to make sure you did not select the reinforced concrete columns. It's only the support. I think all of the support has been selected. Click on the delete options, and then you have to check here the items in which you are deleting. Is it only the support? So just have to, you see concrete wall right here. So unselect all and select only the support. 15 support we are deleting. Click on the OK options to have them deleted. Okay, so you can see we wouldn't have any support again on the foundation mat. All right, so having done that, now click on validate from here. So you see we have validation done successfully. So our model is good like this, you can see. Okay, now we want to proceed to run the analysis again on this model. So the load from the superstructure can be decomposed on the foundation mat right there. Okay, so we come to the analysis tab and then click on this analyze all statics. Now we are good. So all of the load from the superstructure has been decomposed on the mat right here. So you can be able to see the result and the deflections. So if you select on this, you can see the stresses on the mat right there based on the applied load, and the bearing pressure mat right here. You can be able to change between these to see the various pressure and where the pressure intensity is much on the mat as well as the wall successfully using the key right here. Okay, so over here you see we have the drift check. Everything is good. We wouldn't have any issue with this model. All right, so you can see what we have done so far. Okay, so you can also check other options for the stressed check successfully. So once you are done, you can also look at the reinforcement at the bottom. So this is at the area of reinforcement. You can see mm², right? Yeah, these are the area of reinforcement generated. We have up to 550. This is where much pressure is found. Okay, at 550 area of reinforcement, much pressure is found right there. Okay, so you can also check the top reinforcement in the x directions. So you can see we have a maximum of 300 and something millimeters square. Okay, for the top reinforcement. So we have also for the bottom reinforcement right here. This is 590 maximum. All right, over here is the maximum where you see the red. This is the minimum, okay, 66 minimum, maximum, right? Yeah, okay. So over here you can check the value, the pass or fed, and the rest of that. Okay, so here we go. This is our model. We are good now. So we proceed. We have already actually designed the this superstructural element. So if you right click right here and they come to the review view right here, you will see that the superstructural element has been designed successfully. Okay, everything show green, meaning passed. Okay, so you can check them, right click on it, and then you can use these interactive design sections to check it, and then you can see the beams and everything has been designed successfully. All the conditions are passed. You can see. I click on the OK options. What we need to now design is the mat foundation. So you right click from here, and then you can be able to go to the structural view, go to the foundations right here. We want to design the mat. These options we used. Okay, so now we proceed. We don't have anything much to check. Just validate the model right here. Click on this design mat right there. So give the program some seconds to carry out the mat foundation design successfully. Everything is good, you see. So we have 125 members as passed. So we already have issue with the mat as passed design. So if you select this, you can see the reinforcement selections right there. At the bottom, reinforcement will have 16 diameters of reinforcement at 175 millimeters spacing right there. And then at the top, we have 12 diameter reinforcement at 175, both bottom, top 1 and top 2 successfully. And then we have a U ratio of 0.817, which is the mat is actually carrying this model, this structure comfortably, as you can see from here. Okay, so now we proceed. We want to now generate the full 3D reinforcement of this model. The full 3D reinforcement of this model. Then we'll go into generating the structural drawings, detailed drawings for this model successfully. So stay connected. And at this point, if you have not liked, if you have not subscribed to our channel, we are inviting you to subscribe to our channel for free tutorial of structural designs and then tips successfully on this channel of reason. Let's make progress. So to generate or visualize the 3D reinforcement for this model, we use Tekla Structure. You know, this is Tekla Structural Designer. So we use Tekla Structure to do the 3D reinforcement. So I will be activating Tekla Structure. I will click in these provisions and get back to the structural view. So here is the structural view, and then we will activate the Tekla Structure. So here is Tekla Structure. As you can see, this Tekla Structure. So now, if I should navigate back to Tekla Designer, you have to take note of the name. This is basement building. All right, basement building as a name. All right, I get back to Tekla Structure and I click in these provisions. I come to where I have import. Then I go straight away to Tekla Structural Designer. Click the options and this window will pop up. In this window, use these three dot provisions to navigate to where you have the building name. It is basement. We have it to be basement building. This one, basement building. Select it and click on open from here. So once you click on open, leave every other thing here at default and then click on the import right here. So give the program some seconds to import the model into Tekla Structure, where we can be able to see the 3D reinforcement of the structural elements, such as the beams, the columns, as well as the wall and foundations of the building successfully. So let's just give it some time. Okay, over here we need to click on the accept changes options. So once you click on accept changes options, it will load the model just like this into Tekla Structure. Okay, so we have to wait for it to finish. It is now processing the rebar from here. All right. All right, here we go. Everything is done successfully. Okay, so I can move this towards these directions, and here is the model we just imported from Tekla Structural Designer to Tekla Structure, and then all the rebars has been generated successfully. So if I close this window from here, if you want to see the rebar, just do Ctrl+1. You see. So when you zoom closely, you can see the slab reinforcement You can see the beams and the columns reinforcement successfully. Okay, so this is the 3D reinforcement for this model that we have just designed in Tekla Structural Designer. Okay, so you can see the wall itself, and the reinforcement has been generated for the walls, as you can see it right here. You see, that is the wall reinforcement generated successfully. The columns, beams, as well as the slab successfully. Okay, so having shown you this, through these provisions, you can visualize your 3D reinforcement. To the provisions, you can also do your detailed drawings using Tekla Structure successfully. But let's just go back to Tekla Structural Designer. So I will show you how you can also generate your detailed drawings right here. Okay, so for the beam detailed drawings, what you do is you have to come to where you have draw options. So for the draw options right here, you can always come to settings to set or drawing manager. All right, settings, you have to come here to be able to set some of the important settings like the sections for the structural elements. Okay, you know, at default, Tekla Structural Designer will give you too many sections, okay, for your beams. So here you can be able to set the numbers of sections you actually want for the beams. So if you actually you see the members here, so you see member detail, expand this member detail, and then you see beam detail, select it right here. So you have this group beams. Okay, show numbers of beams in groups. You can see the style right there, and then you see the cross sections. If you select here, so you can see section label A, B, C, and so on. So you can use the uppercase or lowercase letter. You can also use the number to actually label your sections. Okay, restart section label in each beams line. Add beams name label as prefixed to section label. Okay, so all of this is what you can set successfully. That is the style. All right, if you come to the longitudinal, you come to the stirrup, you have this. You come to the beam label, you have this print beam labels between the details. Underline beam label, so you can uncheck not to underline, check to underline. You come to the content, and then you see the level right there. You see the cross sections. So over here you can see position, span only, span only. If you select here, you can see support and span. So if you use span only, simply means you get only one sections. All right, so if you use this option of support and span, simply means you get both sections at the support of the beam and then the span of the beam successfully. Okay, so display mark bar. So all of this has been set successfully. So this is how you can be able to navigate through these setting options under the draw tab. I click on the save options and the yes options and OK option. Okay, after which go to the drawings manager. So in this drawing manager, over general arrangement drawing, so you need to select in these provisions to be able to pick the drawings that you wish to actually produce. So you can see slab mat layout. You can also see foundation reactions. So you can see columns right there. You can see beam forces. Okay, so you can also see every other sections that you wish to work on. So you can see concrete beam detail. Let's for instance, we are getting detail of concrete beams. So what you do is just want to select concrete beam detail over here. Click on add from here. So once you add from here, you see over here you see basement building concrete beam details right here. So now you see the content, select right here. This is what you get by grouped. So select on this, pull it to this side, and then if you come over here, you can see all the beams that you actually get here successfully. So with this, if you start to minimize, you can minimize all of this just like this, minimize this, okay, minimize this. So these are the beams you had in this structure. So these provisions you see on group from here down is on group beams. So you can first of all produce the detail for the group and check if all the beams in the building is being grouped. If they are not grouped, you can come over to now apply the on group. So this is the on group and this is the groups. Okay, so we go by the groups first. So now click on the OK options. So now once you click on the OK options, you can come to these provisions where you have view drawings. Okay, so once you click on the view drawings, you have these provisions. See drawing layer configurations, and then you see layer style, and then you see the scale 1:25, and then maximum text block space is 5. So you can adjust this as well. When you are good with this, click on the OK options. So this will automatically open AutoCAD, and then you see the beams. that Tekla Structural Designer has been designed for use successfully. So here is the beams designed by Tekla Structural Designer. So it's using two H12 at the top, two H12 at the bottom for some of the beams. All right. Then you see this beam is being grouped. Yeah, that's why you see 16 of this. All right. Actually in the model 16 of this, and this one is 8 of it. All right. So for this one, all the same thing, and here is the bar bending schedule and the quantity takeoff successfully. So here are the beams for the model. So this beam has been grouped successfully. Okay, so having show you this, I can minimize this right away and close this. So in the same manner, you produce your columns details drawing. So for the columns drawings, let's see what we do. You can click also through this drawing management, okay, and then come to these provisions and change it to columns. All right. So where is the columns? You see columns, concrete column detail. Select that and then click on add from here. So after we click on the content, and then these are the walls that we have here. So by group you have none from here. So WW, all of these are basically for walls. Okay, so let's cancel this and check. Okay, concrete columns, add basement over here. This is concrete wall details. Okay, sorry, this is concrete wall details. All right, so we can also create this. So click on the content, come over here, select on one of these and pull it to this side. I want to pull everything here, so I can select the first one. I can select the first one and see. I want to see how to select all and pull it all the way. Okay, it doesn't allow me to actually pull all, but I can just select some. All right, for the sake of this free tutorial video. All right, so now at this point, click on the OK options. I can view it from here. So everything is good there. Click on the OK option. Okay, so you can see the wall. So this is how Tekla Structure detail the wall. So you can see the sections of the wall from the foundation wall up to the first floor to the third floor. All right, you see the wall thickness right here. Just like this, you can see how you can generate your wall successfully in Tekla Structural Designer. All right, let's get back. So the next one will generate from here. Let's cancel this, get back to the drawing manager. Click in these provisions. We have concrete columns detail. You can see you add it from here, and then after which click on the content, select on this, pull it to this side. All of the columns are here, and then they are all grouped. Click on the OK options from here, and then so we go to view drawings. Click right there. So over here everything is good. Click on the OK options. So we have this also in AutoCAD, just like this. You can see. So you have the column. You can see the column sections right here. The column is 450 by 225 right there, and then we have the end reinforcement and the intermediate reinforcements successfully. And then you can see how neat this is. So with this, you don't really need to do any other editing for these columns. All the details you need is given to you right here. All right, so this is all the column being grouped into 1, 2, 3, 4, 5, and 6. Okay, all the column in the building is being grouped to 1, 2, 3, 4, 5, and 6. You can see. So Tekla Structural Designer take time to group this successfully for you, so you will not have any work to do. So you don't even have any editing to do. All right. So at this point, if you are yet to like the video, hit on the like button. If you are yet to subscribe to our channel, Soft Freezing, subscribe for free structural tutorial on structural software successfully. Okay, so we get back right here. So what is left for us is the reinforced concrete slab detail. So before then, we can also look at the report. So let me show you how you can create a report for beams. Okay, so you can click on validate to actually make sure that you are still on point. Okay, so now over here you see model report. This one you have to select on this first. So once you select on this, you have to navigate to the report that you actually wish to consider. Okay, so now what is active? You can see server model data active. Okay, so that is not what we are considering. So we have to actually get to the building design, this one, and then you make it active first. So after selecting on the building design and make it active, you come to these provisions. You see we actually have concrete and steel. You can move them to this side. All right, and then select on this. You need beams, so you can expand, and then you see the beams summary. You see group design report, so you can move on to this provision. So this is for beam. Okay, so if you expand this, you can see it's only beams you are having for both static and arrow XA. Arrow X, so this arrow XA you see here is just this is for the seismic. Okay, but we have not done seismic analysis. Okay, but assuming you have done it, it is part of the statics analysis you did. Okay, so if maybe you want to have series of report, you can, as you have selected beams, you can also select columns under it, just like this, and then you can also select walls under it. So this will give you a series of report of the structural elements successfully. So let's just go by this tree for now. You click on the OK options right here. So once you click on the OK options, you can see member report, show report. So if you click on this member report, okay, you will also see the concrete beams summary active right here. You see the concrete beams design right here. So I can just click on the close to close this, and then click on show report right here. So this is going to boot and then generate the report for us successfully, which you can view it in a Microsoft Word. You can also view it in PDF, and as well you can view it in Excel. Okay, so let's wait for the reports to be compiled successfully. So you can see the progress right here. Here we go. So you can see, if you hold the control key and screw the wheel of the mouse, you can zoom in to see the code of practice used, and then the member design right here. Okay, so after which you scroll down, you can see the beams, and then you can see the design summary. Bending, you scroll down, you see other design information. So this is the summary of the report of the beams, as you can see from here. So we have a lot of reports here. You can see what we get here. So many reports we have there for the beams. All right, so you can see this is the report for the wall. You know, we selected wall alongside is the wall report right here. From the wall, you can also see columns report. So you can print in PDF, Word, Excel, and so on and so forth. Okay, so now let us get back to the 3D. So you can as well select any of the beams right here, right click, and be able to view the beam report. You can see report for member. If you click on this, this will actually create report for that particular member for you. Okay, it's another method of creating report as well. For any of this member, you can use that same process. All right, so we are good. In this video, we have been able to do a lot of things on how to use Tekla Structural Designer to design the building on basement successfully. So we are going to be stopping here. We have tried for this presentation. So do not forget to like and subscribe. If you have any question, drop it in the comment sections. So don't forget to also check the description of this video. There are some software templates you can also use to fast track your detailed drawing as a structural engineer. Okay, so you can get them download through the link in the description of this video. We'll be stopping here. To see you in the next presentations. Have a great day and bye for now.